Before getting into the next set of exercises, we need to set up a few definitions. The first of which is, what does it mean for a set to have n elements? This means that there exists a one-to-one mapping of n onto x. Let's take a particular example like n equal to 4. Recall that 4 is equal to the set of all numbers less than it, so if there is a one-to-one mapping from 4 onto x, then x must also have 4 elements. A set is called finite if it has n elements for some n in n, and infinite otherwise. That should all make pretty good sense. A set is T-infinite, or T-finite, if every non-empty collection of subsets of S, that is to say, for any non-empty x a subset of the power set, if any such x always has a subset-maximal element, which I will, in words, abbreviate as submax. Now, what is a submax element? A submax element of x is some element of x such that there is no other element of x. I should have written that v is contained in x as an element, but U is submax if there is no other element of x which contains it properly. By contains it properly, I mean contains it and is not equal to it. So that's what a submax element is it's basically something not contained by anything else. So set S is T-infinite if it's not T-finite. T stands for Tarski, that famous logician. Now, let's consider some examples. Let's look at the set of 8, 10, 11 and ask whether or not it has a submax element. Now, if submax element in some sense means the largest, a natural guess for which one might be the submax element is the number 11. 11 is equal to the set 0 through 10, and 8 is the set 0 through 7, 10 is the set 0 through 9. The only one of these that contains 11 as a subset is 11 itself, but that's not proper containment. So 11 is in fact the submax element of this set. Now let's think about T-finite. Take for instance the number 3, and let's investigate whether or not it is T-finite. Well, we want to first consider the power set of 3, which is the set of all subsets. It'll contain the smallest subset, which is the empty set, the largest, which is the set itself, in fact number 3, and it will contain everything in between. Now, we want to think about picking an arbitrary subset of this. So imagine that we take x to be the set of 1 together with the set of 0, 2. This is an arbitrary subset of the power set. We want to ask, does this have a submax element? In fact, I claim that both of its elements are submax elements. This, the set of 1 is a submax element because you cannot find anything other than itself which contains it. Similarly, this is also submax. Okay, let's take another example. Let's in fact take the largest example we could possibly take, and suppose that y is equal to the power set of 3, which is certainly a subset of the power set of 3. So, does y contain a submax element? I claim yes it does, and in fact the number 3 is that submax element. If you took any other element of the power set of 3, it would be a subset of 3, so yes, 3 is the submax element of this y. Let's think a little bit more about these concepts with infinite examples. So suppose that the set S is equal to n, and in this case, S has no submax element. We could always add one, and that set would be in n, and it would also contain n, whatever element you chose. So one question to ask and think about briefly before getting into the exercises: do all and only infinite sets have no submax element? Well, I claim clearly if a set has no submax element and is non-empty, then it has some element, and that has some set that properly contains it, and that has something that properly contains it, and so on, always coming up with genuinely new objects. This would imply that the set has to be finite. So having no submax element definitely implies that the set is infinite. However, if we look at the power set of n, that is clearly an infinite set, but I claim that it has a submax element, namely n itself. N is an element of the power set, and it if you take any other element of the power set, n will contain it, almost by definition. So apparently here we have an example of an infinite set with no submax element. So the implication only goes one direction. We'll start getting into the exercises.